Good morning, middle school students. It is Mr. Manta once again. We had another wonderful day in science class. Today's date is Thursday, April 23rd, and we're moving right along in our chemistry unit today. Today is, in fact, a very exciting day in chemistry because we have a lab. I'm not sure how many of you guys are familiar with this term, but it's one that you're going to be hearing in your science classes more and more and more often as you continue into middle school and high school. A lab is a day where you get to actually do some science. Get to actually collect some data, watch something happen, and do the fun parts of science. But you also got to do a report and figure out what it is that you're actually learning about in the lab. And today we're going to do a lab by using a simulation online. We'll get to that in just a second. But first, we're going to start, as we always do, with today's Do Now. Go ahead and make sure you have your science notebook out. Label it today's lesson, which is Lesson 8, the Solutions Lab, and number questions 1 through 4. And those 4 questions are the ones that you'll find right here about Miss Merrick, who is trying to make some very sweet Kool-Aid. Well, testing whether you really remember all that vocabulary that we learned yesterday about solute and solvents and all that. So go ahead, pause this video, and answer these 4 questions in your notebook now. Alright, I am now assuming you've unpaused the video, you've answered the 4 questions, because we're going to run through the answers. Number 1, Miss Merrick makes Kool-Aid by mixing Kool-Aid powder into a water bottle. In this scenario, what is the solute? Well, the solute is always like the solid thing that you add into the mixture to make your solution. So what is the solute? In this case, it's the Kool-Aid powder, the solid powder that she's pouring into the glass. What is the solvent? Well, the solvent is like the liquid that is the basis of the mixture, the thing that's being dissolved into. And so here it would be the water. What is the solution? Well, the solution is the mixture itself. So it's the Kool-Aid that she makes. It's that end product of Kool-Aid powder and water mixed together, which is Kool-Aid. And our 4th question, Miss Merrick opens 4 more Kool-Aid packets and keeps adding them into the water bottle to make it sweeter. However, she eventually notices that the Kool-Aid powder is just collecting at the bottom. What happened? Well, we learned yesterday that whenever we make a solution by dissolving a solid into a liquid, if you eventually add too much of your solute, the solution becomes saturated. That's that word we learned, which means that it can't dissolve any more solute. The water reached the maximum point of the most amount of Kool-Aid it could possibly hold in it. And so instead of continuing to dissolve, that extra Kool-Aid powder she's adding in that 3rd and 4th Kool-Aid packet is just going to go collect at the bottom. Yesterday, we saw that really happen when Mr. Manta did my own little solution demonstration here, and I kept adding salt, more and more and more and more salt to the small amount of water, and eventually the salt water became saturated, and no more salt could dissolve in it, and it just collected solid salt down there at the bottom. To recap the words that we learned yesterday when we were making solutions, we said that you always have a solute, in this case the salt, that's the thing that you're mixing in. You have a solvent, in this case that was the water from my water bottle, that's the liquid that the solute's gone into. And you have the solution, which is the mixture that you end up with of something dissolved in something else. We also learned a little bit more vocabulary, just that we're all clear. We learned this word dissolve. Dissolve means that when a solid is mixed into a liquid and breaks down into its particles, so that it's perfectly evenly distributed. We learned this word saturated that we just talked about. That's when a solution has the maximum amount of solute possible dissolved in it, and you can't dissolve anymore. So like once we added already a ton of salt to that water, we couldn't dissolve any more salt because that salt water was saturated. And we learned the word solubility, which is how much a substance can be dissolved into a solution before being saturated. So we saw that salt is pretty soluble. That means that we can keep adding a lot of salt into water. We had 2 whole tablespoons before that water got saturated. So salt is pretty highly soluble compared to something like sand, which isn't very soluble. Now, I also want to give a few shout-outs, because I said yesterday, if you did this demonstration at home, please send me a picture, and I've had 3 students so far who did that demonstration and sent me pictures and videos of it. We got Zantez over here, we got Janaya in the middle making her saltwater solution, and we got JL. JL also included a hypothesis. She figured out that if you change the temperature of the water, you can't dissolve as much solute into it. So really cold water can't dissolve very much salt at all. But if you make the water really hot, then you can keep on adding more and more and more and more salt. So thank you to all of you guys, and maybe you're going to see yourselves on the Great Lakes Academy Instagram page sometime soon. We will see. And hopefully we'll have more opportunities for demonstrations like this one in these next couple of weeks as we continue to advance through chemistry. Now, for today's big question, we want to take this to the next level and compare, like yesterday we were just talking about salt as our solute, just salt and water, really plain. Well, what if instead of salt we had used sugar? Or what if we used brown sugar? What if we used Kool-Aid or lemonade mix or something like that? Would we still be able to dissolve that same amount, those 2 tablespoons? I don't know. Today's big question is going to be, do different chemicals have different solubility? Again, we learned that word solubility yesterday. That means, can different chemicals dissolve different amounts in the same amount of water? Like maybe I can only dissolve 1 tablespoon of sugar, but 2 tablespoons of salt. I don't know. Or maybe they're all the same. To find that out, we're going to go to, oh, wait a minute, not Crash Course. We're going to go to the lab. We have no Crash Course video for today. Instead, we're going to have a lab that looks something like this. Let me show you how you're going to get to it and how to exactly use all this crazy stuff that you're looking at on the screen. So, assuming that you are on Google Classroom, your Google Classroom page should look something like this. And today, Thursday, April 23rd, you're going to have 2 assignments listed here. One of them is the link to the simulation we're about to use, and then one of them is a Google form to answer the questions about today's lab. So the first thing you're going to do is come to the simulation link and click this link right here. That will open up a web page that looks like this. To open the simulation, you just got to click the big play button that you see on it right here. And then that will take you to a web page that looks like this. Here is today's simulation. Now, when you first open it, I encourage you to spend a couple minutes just kind of playing around with it before actually recording any data. But I'm going to run through the basic tools of how it works. You're looking at a lot of stuff right here, so I'll explain one thing at a time. First of all, this big kind of square-shaped area, rectangular-shaped area over here, is supposed to be a giant basin of water, like a big sink or a beaker or something like that. And you can fill it up more by opening this sink up here and adding more water, or you can empty it out more and drop the level by opening this faucet down here and releasing water from the sink all the way down to the bottom. So you can add more water or release water. What you can also do, though, oh, and you can also, if you want, you can get rid of more water by increasing the evaporation, however you like. The amount of water is not so important, though. But what's cool about this simulation is that right up here you have this little thing that looks like a shaker, like a salt shaker or something, but instead it says drink mix. You can take this little shaker of drink mix and shake it back and forth, and it will pour out what might be, I don't know, Kool-Aid powder or something like that, to pour into the water and to create a solution. So to review our vocabulary, this guy up here is a solute. What we've created here is a solution, and that water that we were using is our solvent. You have a solute being dissolved into a solvent to create a solution. And what you'll also notice, as we keep on adding more and more and more drink mix, the water gets more and more and more red, darker and darker with all that drink mix, until eventually it hits a point where it says saturated, and you can't add any more. If I try to add more drink mix now, I just see that all these little drink mix particles are collecting on the bottom, kind of like when we messed with the salt water yesterday. I have a couple more tools I want to show you, so I'm going to reset it by removing all of that solute. And I want to focus your attention on this little strange purple thing over here. Now this is like a magical science tool that you can use to measure the amount of like the concentration, which is a word for like how much solute is dissolved into your solution at any given time. So all you have to do is take the little thing here, right here that looks like a crosshairs, and put it over your water. And magically, as you add more and more drink mix to your liquid, you will see that the concentration numbers over here are going up. So it started with 0, now I have 1.584, and as I add more and more and more and I make the solution more and more saturated, the concentration is increasing. So now it's 3.6, and it keeps on going up and up and up and up and up, until eventually the solution becomes saturated and the concentration maxes out at 5.960, and then I can't add any more solution no matter what. I can't increase the concentration beyond that. Now the units that you have here are a complicated thing that we haven't learned about yet called moles per liter. So really I just need the number 5.960, and you can maybe write MOL/L if you want to show the units, but I'm not going to right now. I'll go into what it is that means. Just know that that's a measure of like how dense this solution is with that solvent. The last part that I also want to show you is if I come all the way up here at the top, we see that the current solute that we're using is drink mix, but that is not my only choice. If I click on this menu, it actually shows me a whole bunch of fun chemicals that I can use to instead dissolve into my water. Things like cobalt-2 nitrate and potassium dichromate and my personal favorite one to say down here, potassium permanganate. And these are all different chemicals, and you can see whether or not they have a different maximum concentration. So the question today is, do all of these chemicals reach that same maximum concentration when they become saturated, or do they become saturated kind of at different points? Here's what you're going to do. While you are playing around with this simulation, you are also going to create a little table in your notebook that looks like this. It just has two columns that say the name of the solute and the maximum concentration that you're able to achieve. In the simulation, you're going to pick 5 different chemicals. So I think there's 9 total. You don't have to do all 9 of these, but pick whichever 5 you like. If you want to do potassium permanganate because it sounds fun, then go ahead and do it. And then pour that into the solution that we got down here and see how much you can add before that solution becomes saturated. Then you're going to take a look at what the concentration was right here when the solution became saturated, and you're going to record that in your data table. So for example, I'll do cobalt 2 nitrate as an example. I'm pouring it into my solution, increasing the concentration more and more and more and more and more until eventually, let's see, okay, it became saturated and it maxed out at 5.640 moles per liter. I would come back here into my notebook and I would write down that the first solution I chose was cobalt 2 nitrate and the maximum concentration was 5.640. And then I would pick another solute and write out its maximum concentration and another and fill out all 5 rows of this table in your notebook. Then your last step is to use that data. So you're collecting data here. All these numbers, you're going to create a whole bunch of data about concentrations. You're going to use that data to complete the lab worksheet on Google Classroom. And I can show you that in person too. If I come out back here to our Google Classroom page, this one's going to be called U6L8 Solutions Lab. And if you click this form right here, it opens up the lab form. And this is just going to ask you, okay, what was the first solute that you chose? We say, cobalt 2 nitrate, and then you type out what was the maximum concentration that it was able to achieve, like that. What was the second one, the third one, and so on. And then at the end, it'll also ask you a few questions about what your findings were. Ultimately, what we're trying to figure out is if all of these different chemicals have the same solubility or different solubilities. Is one of them the most or the least soluble? How do they all compare? All right. Ladies and gents, that is all that we have for today. Today's video is short because I want you to go spend more time with the simulation itself. If you have any questions, go ahead and post them in the comment. I'll try to keep an eye on it and answer those questions as they come in. And today's cool thing is that this company, this group that makes all these simulations, we've used one of them before. They're the same group that made the skateboarder simulation that we played with back in our energy unit. And I just want to show you guys, if you are on the main page where we have the simulation link, today's cool thing, optional if you want to look into it, is that you can go and play with all the other simulations that they have too. All you have to do is instead of clicking the play button here, you come up to simulations, and I recommend clicking the one that says HTML5. That means that they can just run in your computer right there on the website. And these are all of these fun different simulations that they have on their website. So there was our energy skateboarder there if you want to mess with that guy. Or they even have some math stuff like fractions and whatnot. Some cool stuff that you can add. Acids and I mean, a lot of this stuff is going to be too advanced, so I don't know if you guys are going to understand atomic interactions so well. But hey, take the challenge. Impress me. See what you can do. Alright guys, that is all that we got for today. Your goal for today to be complete is to complete this solutions lab with the data that you got from the simulation. That's all we got. Take care, and I will see you at the start of next week.